Hello everybody, welcome back to Hype. My name is Pranjal Jain and today we are going to understand this question called subsets. First of all, we are going to understand the question, then we are also going to look at its code. So watch the entire video so that you can get to know how to solve this particular question. So let's get started. Subsets. Given an integer array nums of unique elements, return all possible subsets, the power set. The solution set must not contain duplicate subsets. Return the solution in any order. So let's have a look at how we are going to solve this. Let's take this example 1, 2, 3 and see how many subsets can we actually create. So power set is basically a superset that contains all the possible subsets of a particular set. So the set given to us is 1, 2, 3. So in our code, we are going to use recursion. So we'll create the recursion tree for what we are going to do. So initially we are going to have an empty set. At index 0, we are going to have two options, either include it or leave it. At any particular index, we are always going to have just two options, either include this number or leave this number out. So from here, we get two branches, one without including one, and the other that is including one. The difference is that the index moves forward in both of them. So let's write the index as well. Initially, it was 0. Now it is 1. Again, we have two options, either include 2 or don't include. So let's say we have this subset without including 2 and the index becomes 2. And here we have a subset with 2 and the index becomes 2. Same goes for the other branch. Here we have a subset with 2 with index 2 and without 2 with index 2. Now moving forward, we are at the second index. Again, we have two options for each of these branch. Either we have to include 3 or we have to leave 3 out. Let's draw this further. So this is without 3 and the index becomes 3, and this is with 3 and the index becomes 3. Even here we have two options. Either we can include 3 or leave 3 out. Index is 3 for both of them. Even here we have two options, include 3 or leave 3. Include 3 or leave 3. So now that the index is 3 and basically we are out of bounds for this particular vector, all the branches have given us one answer. So this is one answer, second answer, third, fourth, fifth, sixth, seventh, and eighth answer. So these are basically the subsets that we have to include in the answer. So you can see we have all the subsets. Let me list all the subsets down. So first of all, an empty subset. Then we have a 3. Then we have a 2, 3. Then we have a 2. Then we have 1, 2, 3. Then we have 1, 2. Then 1, 3. And then we have a 1. So this is basically the answer that you are looking for. We are going to use the concept of recursion included with backtracking. We're also going to use backtracking in this particular concept. Let us see how we are going to code this in. First of all, we are going to create a vector of integers. So this is our vector of integers. This is basically the answer that we are going to return at the end. Then we are going to create a vector where we are going to contain the current subset that we have created. Let's name it vector itself. Let's call the recursion function, the function that is going to call itself. So we'll pass in this the answer vector of vector, the vector that has been given to us, that is nums, and an index. So this is all we need. Remember, we use an index to find out which index we are currently on of this nums vector. Now let us create, at the end, what we have to do is we have to return the answer. Right? We have to return a vector of vector. We have named it answer. Let us now create this recursion function. It will not return anything. It will only put all the answers in the answer vector. Now let us catch all the parameters one by one. It is vector of integer. That's one. Second, vector of integer. And then another vector of integers, that is nums. And then finally, an index. So we have got all the parameters that we require to solve this particular question. Let us get started with it. So what is going to be the base condition or the stopping condition for this particular question? So if the index has become equal to nums dot size, that means we have come out of bound for that particular vector, nums. So in this case, what do we do? In answer, we are going to push back the vector, the current vector that we have created, the current subset that we have, and we are going to close this particular branch. If this is not the case, then we need to call two recursions, one including the number at index and the other without it. So let's see how we can do that. So here we're going to call recursion with answer, vector, nums, and index plus one. So this basically is the recursion without including the number at index. Next, we'll push back the number at index, nums of index, into vector, and we'll call the recursion once again. Because we are making use of the backtracking concept, we're going to delete this number that we have added after calling this particular function. So vector dot pop back, and that's it. So as you can see, these recursion codes are really small. Why? Because we only have to enter the code for a single step and then call the recursion for the next step. So generally, if you are using backtracking or just recursion, the codes are really small. And once you get a hang of this particular topic, it gets very easy and it saves a lot of time during the exam or the company coding interviews. We have made an error over here. It's you, not I. Let's try to run this now. So both the test cases that were visible have been passed. Let's try to submit this. So all the test cases have passed and the solution has been accepted. Thank you so much for watching the video. If you liked the video, make sure to like, share, and subscribe to our channel. If there is any doubt whatsoever, please comment it down below in the comment section. I'll be more than happy to answer all your doubts. Thank you so much. See you in the next video.